Okay, good morning, everybody. Hope you had a great weekend. Let's let's go ahead and get it going here. So we had that weird 2-day week last week, and we chose to spend those 2 days just doing that one little section. That technically ended chapter 4, but we are not going to have a test over that because we did most of chapter 4 before break. What we are going to do is at some point we're going to have either the computers in here or we'll go down to the library and do that state practice test run through thingy on the quadratic equations, because that's the next section. We did that once in the fall on the linear functions. Now we're going to do it on quadratics. We'll probably do that at some point next week. Yeah? The test that's going on this week? No, I mean this like 14 through... Oh, I didn't know that there was a test going on that week. Which? Oh. Maybe that's finals. Yeah, because the end of the semester is right here. And so what they try and do is they say these subjects have their, if you're going to have a final, do it on these days to try to keep you from having too many finals on the same day. I think so, but I'm not 100% sure. I haven't seen that. We are not going to have a final in this class. No. Ashlyn? I asked Miss Herzog on Friday if she would email them to me, and she said she would, but she has not yet done that. She has them, yeah. Yeah, the people that retook the math thing, yeah. Hopefully you passed, yeah. No. It's only get one shot. All right, so the upshot of that conversation is that we're going to dive into chapter 5 today. Okay, yeah? I reserve the right to give you a final at the end of the school year, yeah. But I might not. Right, exactly. I might waive that right later, but I'm saving it right now. Kind of depends on how far, like, do I feel like that time best spent covering more, or have we learned everything we need to know, and so now we can, like, test on it? And have you been good students? Anyway, so for chapter, our game a little bit, in chapter 3, about quadratic functions, and in chapter 5 we're going to talk about polynomial functions, and so we're just building from what we have done previously. Yes, ma'am.
I saw you walking yesterday.
Yeah, well, you should be like, nice job, Mr. Aldrich, because it was like 39 degrees and pouring rain, and we went out for a walk anyway. So what's that?
That's how you get in a
That's okay. That's all right. Yeah. Oh, no, we kind of skipped over that, didn't we? Yeah. So no. Okay. All right. So polynomials. Polynomials go like this. You start out with a monomial. Let's get a couple of examples of monomials. First of all, somebody give me a number. 1. Somebody give me a variable. A, and give me another number. 2. Okay, so 1a squared is an example of a monomial. Okay? It's just got one term. That's what mono means. Okay? There's no plus or minus anything else. It's just 1a squared. All right? Let's get another one going here. Give me another number. 3, I heard. Give me another variable. L, and then give me an... Okay. 3L to the 4th is another example of a monomial. I know that it's got more than one piece, but because there's no plus or minus, that's just technically one term, and so that means it is a monomial. Okay? Does that make sense? Monomial. 1. All right, each one of these monomials also has a degree. The degree of the monomial is the exponent. So what is the degree of this monomial? Good. That has a degree of 2. What is the degree of that monomial? 4. That has a degree of 4. So whatever the exponent of the monomial is, that tells you what the degree is. Okay? So that's because mono means 1. What does poly mean? Multiple. Good. So like a polygon is, sorry, got stuck there. Polygon is a shape that has multiple sides. Okay? So a polynomial is multiple monomials, multiple nomials, polynomial. So in other words, if I took these two monomials and added them together, then I would have what we're going to call a polynomial. And the fun thing about polynomials is you could really have as many of them as you wanted. So give me another number. Give me a variable. Give me another number. 6. Okay, so I could also tack onto there negative 2f to the 6, and that's still a polynomial. And I could add on as many of those as I want, and I would still be in the polynomial land. And so that's what I meant at the beginning when I said we're starting, we did linear, did quadratic, now we're building. We can use as many terms as we want, and our exponents can get as high as they want them to be. So the question now is, since I have more than one term here, how do I determine the degree of that polynomial? Chris? Good. We just choose the highest exponent that's listed. And so in this case, that would be 6. Okay? So a monomial only had one term, so it's easy to figure out what the degree was because it just was whatever the exponent is. Polynomial has more than one term, so to figure out the degree of that, we just take the highest exponent out of all of them. All right? Does that make sense? No, it's easy. There is no but. It's just easy. No, it's not going to get more difficult today.
I know it's today also.
No.
Because I don't get how we do this like everyday life.
Yeah, I've been thinking about that you and some other of your friends like are always, oh, when are we going to use this? Really, everything I teach in this class, I teach it to you for 3 reasons. 1 is it's on the state test. 2 is it's on the college placement test. And 3, it's used in future math classes. And that's the best that I can do. There's no way that I can teach you things that you're going to use in your real life because you guys are all going to go on to have different lives. And so all we can do is just prepare you to make those choices later on. So there's really no reason for you to ask that, when are we going to use this? It's on the state test, it's on college placement tests like the SAT test, that kind of stuff, and it's used in future math classes. That's all I got. Callista? Yes, that's what I mean by college placement test. Yeah, so this kind of stuff would determine what college class you would be put in. Yes, ma'am. What's that? Oh, okay, I'll teach you how to do taxes. You ready? Yeah. Are you ready? That's how you do your taxes.
Really?
Yeah, you go to TurboTax or you go to whatever, and they say, enter this number in, and you do. And they say, enter this number in, and you do. And they say, enter this, and then you do. For you guys, it'd take like less than 5 minutes. This is how much I made. This is how much I paid in taxes. They'll say, this is how much you either get back or this is how much you owe. There's no math that you have to do for that at all. Sorry. Again, the reason for that is because of the 25 of you, you will all choose different paths in life. And so we don't know what those all are going to be. It would be impossible. Like what? I'm serious. How do you get a job? That's not math.
I know, it's not math.
That's like, yeah. Okay, So this is what we were just talking about in like a fancier thing, okay? The only thing that's important on this page is what we're going to be doing is we always want to get the polynomials written in standard form, which means this is just what your math instinct tells you to do anyway. That means the highest exponent is first, and then the next highest, and then the next highest, and then the last one. So you don't need to write down this whole slide. There's a bunch of confusing stuff on there. All you need to know is standard form means put the exponents in order, and that's what we are going to do. This bad boy, however, is muy importante. This is like what it's all about. We'll make that as big as it can possibly be, because one of the things that we would like you to be able to do is to name polynomials, okay? And when I say name polynomials, I don't mean I'm going to name this polynomial David, and I'm going to name that polynomial Mackenzie. We mean name them based on the polynomials themselves, okay? Yes, so just like you and I, polynomials have two names. They have a first name and a last name. These are the first names, and those are based on the degree of the polynomial. And these are the last names, and they are based on the number of terms that the polynomial has. Yeah, I would definitely write this down, okay? Yeah, pretty much. So I'll just yak at you while you guys jot this down. So if you have a polynomial with a degree of 0, that means, like this example right here, if it's a degree of 0, that means there is no variable in the polynomial, so it's called a constant, okay? If you have a polynomial whose highest degree is 1, then all of those, if you graph them, give you straight lines, so those polynomials are called linear polynomials, okay? If you have a polynomial whose highest degree is 2, those are the ones we just finished studying. Those are called quadratics. Hopefully you knew that already. And then the 3, 4, and 5 are the ones that we're going to add on that we haven't studied together yet. If your highest degree is 3, then not surprisingly, that's called a cubic, right? Because when you raise something to the third power, you are doing what to it? Cubing it, okay? Alexandria? Polynomials are about both the exponent and the number of terms. So I'm just focusing on the exponent part now, and then we're going to talk about the number of terms in just a second. If you have a polynomial of degree 4, then that's called a quartic. We won't see very many of those, but every once in a while we'll come across them. If you have a polynomial of degree 5, those are called quintics, like quintuplets is when you have 5 kids, right? Makes sense? Okay. So that's the first name. You just look at the highest degree of the polynomial, and that tells you what you got, okay? The second name is based on how many terms you have. So if you only have one term, then it's a monomial, because mono means 1. If you have 2 terms, then it's a binomial, because bi means 2, like bicycle, bifocals, bicentennial, 200 years, right? Okay. This is a monomial again. If you have 3 terms, then it's called a trinomial, like a tricycle or a triceratops. 3 horns, triangle. Thank you. Okay. This one is a binomial again. And then for the name using the number of terms, if you get up more than 3 terms, then you just say it's a polynomial of 4 terms. So there is no special Latin name or whatever for that. Okay? Okay, so for example, if I have 3x plus 9x squared plus 5, hopefully your math instinct, first of all, says to you that there's something wrong with this picture that we need to fix, and that is that it is not in standard form. Vili, can you tell me how I would write this in standard form? What? This one right here? 9x squared plus 3x plus 5. Good. So highest power comes first, and then the next one, and then down from there. So that is it in standard form. Okay, now that we have it in standard form, we can name it. Sydney, what's its degree? What's the highest exponent that it has? 2. So that means it is a quadratic. That's its name based on the exponent. Then we also need to give it a name based on the number of terms that it has. David, how many terms does it have? 3, so that means it's a quadratic trinomial. Okay? Make sense? Yeah, we just named it. Quadratic trinomial. Yeah. Because David told me that there were 1, 2, 3 terms there, and 3 is tri, so it's a trinomial. Okay. All right, let's do the next one. Chris, can you write that in standard form first? You mean to, can you see? X to the 4th. Good. So what Chris notices is that we have some like terms to combine there. We got negative 6x squared plus 10x squared, so those are combined to be 4x squared. Awesome. And then? Good. All right. So that's it in standard form. Highest exponent first, and then the next one, and then the next one. So now that we have it written like that, let's name it. What is the degree of that polynomial, Alexandria? 4. So that means it is a quartic. And then the second name comes from how many terms it has. How many terms does that have, Sage? Good. So it's a quartic polynomial of 4 terms. Okay? Because we don't have a name for if it has 4 terms. Oh, no, ma'am.
Why not?
Yeah, it could be like 8. Mind blown. All right, so we're good there. All right, the reason why we want to be able to classify those is because if we know that stuff about the polynomial, then we automatically, without graphing it, know some stuff about the graphs, okay? And so this is when we go to, cheerleading practice, or else I think about the guys with the flags that bring the planes in. You might have a graph that is up, okay? And that means that the right side of the graph is pointing up, and the left side of the graph is also pointing up, okay? Not yet. You could also have a graph that is down, down. And that means the right side of the graph is pointing down and the left side of the graph is pointing down, okay? Or by making a little change, which we'll talk about in a minute, you could have a graph which is down, up, which means right side down, left side up. Or of course we could flip that around and have a graph that is up on the left side and down on the right. Yes?
So with the table, for this data,
I would have to look specifically at the learning targets to know if you have to memorize the names. I don't think that you do, no. Okay? Okay, so the way that you can tell if it's up, down, or down, up is by looking at a combination of the degree of the polynomial and whether it's positive or negative, okay? And that table looks like this. If the degree, hold on, let me pick a better color. Abby, just a second. If the degree is even or odd, or if the first number is positive or negative, that tells you what the graph is going to do. Abby? Side to side, like straight across this way? Yeah, that's a great question. The only time that will happen, and it will always happen with this type of polynomial, is if it's a constant. Okay? That's a really good question. And I guess that's sort of locked up in here because a constant has a degree of 0, which is neither even nor odd. And so that means it doesn't do any of these things. Good question, though. Okay, so if you look at whether the first number is positive or negative, and then if you look at whether the degree is even or odd, that will tell you what is crack-a-lackin' with the graph. Okay? So you guys have a chance to copy that down, and then we'll go back and I'll show you how that relates to those 4 graphs that we have up there. Lots of notes today, huh? But it's easy stuff. Almost, but I got one more thing to learn you. Okay, so we go back. You didn't say that word correctly. When you're saying it in that context, it has 2 syllables. It's no. Yes. Oh, yes. Yeah, and that's the technical term for that is called the lead coefficient. So the number in front of the first thingy is that. All right, so the way that that works is if I look at this, what is the highest exponent? 4. Is the first number positive or negative? Positive, so that means this is even positive, and so even positive is going to be up, up, okay? If I look at the next one, whoops. If I look at the next one, this is the highest exponent there is also even, but this time the first number is negative. So that means that would be an even negative. So if we go to the chart, even negative is going to be down, down, and then you do the same thing with these other ones here, okay? So for example, oh, you didn't get the chart written down? Or you wanted to write the examples down? Let's write these examples down, okay? Luke. Is the degree of the polynomial there in part A odd or even? Odd, good. So this has a highest power of 3, so that means it's odd. Is the first number positive or negative? Positive, so that means this is an odd positive. So if you look at your chart, what will an odd positive do? Odd positive will give you a down-up graph. Okay, so this number right here, Luke correctly said, was odd. This number right here is positive. So that means it's an odd positive, so that means it's down up. Sorry, McKenna. Okay, Colby, is the degree odd or even? Even, because the degree is 4 and that is an even number. And is that number positive or negative? Negative. So we got ourselves a what kind of graph? Down, down. Okay? Got one more thing, and it's super fun. You're going to love it, okay? There is a way that you can tell the degree of a polynomial just by looking at the table of values that the polynomial gives you, okay? Nope, not by Desmos. We don't even need Desmos for this. We just need our little old Brians for this. Oh, there's a negative in front of the, okay. So, for example, if I look at this table of values here, and you were to say what degree polynomial would produce those numbers, here's how you do it. How far is it from -1 to negative 7? Negative 6, down 6, right? How far is it from -7 to -3? Up, yep, +4. How far is it from -3 to 5? 8. How far is it from 5 to 11? Up 6, from 11 to 9, and then from 9 to -7, down 16. Okay, those numbers are called the first differences because we got them by subtracting the numbers. If the first differences were all the same, then that would tell us that the polynomial would have a degree of 1 because first differences would be 1. Okay, they're not, so let's keep going. How far is it from -6 to +4? Up 10. From 4 to 8? From 8 to 6, subtract 2, good. From 6 to -2, -8. And from -2 to -16, -14. Okay, those, not surprisingly, are called the second differences. Yeah, and if those were all the same, then our polynomial would have a degree of 2. But they're not the same, so we need to keep going, okay? How about +10 to +4? -6. How about +4 to -2? How about -2 to -8? And -8 to -14? -6. Okay, so those are the third differences. And those are all the same, and so that means that the polynomial that produced these numbers is a degree of 3. Okay? If we had to go one more step to get all the numbers to be the same, then it would be a degree of 4 and so forth. Okay? And that's it. That's all I got. Okay?